I'm going to work a few of the problems from the Dividing Complex Numbers practice worksheet. Specifically, I'll be working on 5, 8, and 10. So let's start with number 5. Whenever we have I in the denominator, just the imaginary portion, in order to divide, all we're going to need to do is multiply by I over I. When we do this, we're going to end up distributing the I on top, and then down below we just have 6I times I, which is 6I squared. So let me go ahead and distribute. I times 7 is 7I. I times negative 4 is negative 4I squared. And then on the bottom we still have 6I squared. Then you'll recall that I squared equals negative 1. So wherever we see I squared, we can go ahead and substitute in negative 1. So I'm going to have 7I minus 4 times negative 1 over 6 times negative 1. That's going to give me 7I minus a negative 4 is going to be plus 4 over negative 6. Now remember, whenever we write a complex number, we write it in the form, so complex numbers are in the form of A plus BI, so the real portion is first. So in this case, my real portion is going to be my number. So I'm going to rewrite this like this. And now we need to break it into two pieces. So this will be 4 over negative 6. And then the second portion is the imaginary, 7 over negative 6I. Now you'll notice that this portion can be reduced further. So I'm going to say that's negative 2/3 plus, well, let's go ahead and just change that into a minus and stay in plus of a negative. So that'll be minus 7/6 I. And that is the answer to number 5. Alright, let's go ahead and write up number 8 next. 8 was 7 plus 4I over negative 2 minus 5I. So when we do this, we need to multiply the top and the bottom by the conjugate of our denominator. So the conjugate, everything stays the same except the middle sign changes. So instead of negative 2 minus 5I, we're going to have negative 2 plus 5I. Now I'm going to go ahead and multiply both sides, and I just like to put these in parentheses so it looks like what I'm used to multiplying. Alright, on top I'm going to have 7 times negative 2 is negative 14. 7 times 5I is 35I. Then I'm going to have 4I times negative 2, which is negative 8I. And 4I times 5I, which is 20I squared. Then we're going to do the exact same thing below. So I'm going to have negative 2 times negative 2, which is 4. Negative 2 times 5I, which would be negative 10I. Then we're going to have negative 5 times negative 2, which is a positive 10I. And negative 5I times 5I, which is a negative 25I squared. So as is always the case, whenever we multiply something by its conjugate, these middle terms are going to drop away to 0. So we're just going to cross those out. In fact, when you're doing this, if you can remember that pattern, you don't even need to write them out. So up top I've got negative 14. I'm going to combine those like terms. So 35 minus 8, that's 27I, plus 20I squared. Down below I'm going to have 4 minus 25I squared. Then again we're going to remember I squared equals negative 1. And we're going to substitute that in. So negative 14 plus 27I plus 20 times negative 1 over 4 minus 25 times negative 1. So up top we're going to have negative 14 minus 20, that's going to give me negative 34. Then we're still going to have our plus 27I. Down below we're going to have 4 minus a negative 25, so that's going to be 29. Now I'm going to go ahead and simplify this a little further by putting it in a complex form. So negative 34 over 29, that's my real portion, and then 27 over 29i, my imaginary portion. Together they make up my complex number in standard form, and that is my answer. Alright, let's go ahead and do the last problem that I'm going to work, number 10. Number 10 is just like all the others, it's just got a little bit more complicated algebra. But the process will be exactly the same. So like always, what do we have to do? We have to multiply by the conjugate of the denominator. So now all I'm going to do is change my sign in the center. So instead of the square root of 3 minus I, I'm going to have square root of 3 plus I. Then I just need to multiply things out. So let's go ahead and do that. So 1 times the square root of 3 is the square root of 3. 1 times I is I. Negative 3i times the square root of 3 is negative 3 square roots of 3i. And negative 3i times I is negative 3i squared. Now we're going to do that all over again on the bottom. So square root of 3 times the square root of 3 is just 3. Square root of 3 times I is square root of 3i. Minus I times the square root of 3 is minus the square root of 3i. And minus I times I is minus I squared. Now once again, those center terms fall away. And we can use the fact that I squared equals negative 1 to simplify this some more. So I'm going to have the square root of 3 plus I minus 3 square roots of 3i minus 3 times negative 1. On the bottom, I'm going to have 3 minus, oh, I forgot to replace that there, 3 minus negative 1. So let's keep going here. Up top, I'm going to have, well, over here, we're going to have this negative 3 times negative 1 is going to be positive 3. So I'm going to move it over by my other real number. So I'm going to have square root of 3 plus 3 plus I minus 3 square roots 3i. And then down below, a negative times a negative is going to be a positive here. So I'm going to end up with 3 plus 1, which is 4. So that will be just 4. Okay, now to get our real and imaginary stuff together, things will get a little more complicated, but not too bad. This is my real section over here. Negative, or the square root of 3 plus 3, and I'm going to put that over 4. And then over here I still have I minus 3 square roots of 3i over 4. But I've got I in two places, which I don't like. So what I'm going to do is I'm going to factor out the I, so I only have it in one place, and it's going to look like this. The square root of 3 plus 3 over 4, plus, if I factor out one I here, I'm only going to have 1 left. 3 square roots of 3 on this side, over 4, all times I. So if I were to multiply this back out, I would get I minus 3 square root 3's of I. So this is the same expression. It's just written in standard form. I hope that helps you.